Welcome to Brain Vision.
Once again, welcome to a new problem on energy and motion. In this case, we have like um, a soccer player. Okay, we have a soccer player, and they're gonna kick a ball. Okay, we have a soccer player, and they're gonna kick a ball, and the mass of the ball happens to be 0.420 kilograms. The ball itself is moving with an initial speed of 2.00 meters per second. And so the player kicks the ball with a force of 40 newtons. That's what's happening, 40.0 newtons in the same direction as the ball. Remember, the ball was already moving. The ball was in motion. And so the player gives it additional motion, okay, by kicking it. So we want to know like, what's the distance that the player's leg has to move? Okay, what's the distance that this player's leg has to move such that the final velocity of the ball is going to be 6 meters per second. So that's what we're doing in this problem. We're going to use the work energy theorem because it has, the total work is seen as change in kinetic energy, which is 1/2 mv final squared minus 1/2 mv initial squared. That's the total work. But then remember, the player is exerting a force through a displacement s. So these two are equal. The force times the displacement, that's the work being done on the ball, and it's exactly the same as the change in kinetic energy. So if F times S equals to 1/2 mv final squared minus 1/2 mv initial squared, our goal is to get the distance S. So we divide both sides by the force. Okay, we divide both sides by the force, and then simply plug in the numbers. So 1/2 times the mass, which is 0.420. And by the way, the upper part, you could pull out the 1/2 m and just have v final squared minus v initial squared. It's algebraic, so you could always do that. And so right here we have 6.00 meters per second. We have to square that, minus 2.00 meters per second. We also have to square that. And all of that is divided by the force, which happens to be 40 newtons. Remember, they're all in SI units. You always have to keep them in SI units. So this is, I need to change that. So this is, let me use something else. This is, put the line there. Yes. This is 40.0 Newton. And so if you divide it, you get 0.168 meters, or you could say 16.8 centimeters. Okay, that's the distance the player has to move their leg to kick the ball such that it's going to have a final velocity of 6 meters per second. So thank you very much. Feel free to comment, ask any questions, clarify on energy problems, work energy theorem. We have a player with the ball, kicking the ball with an initial velocity. We don't know what distance he has to move so that the ball has a final velocity of 6 meters per second. But then in the process, we know the force is 40 newtons. We use the work energy theorem. Change in kinetic energy equals to the total work done. Remember, work is force times displacement. And so we'll end up with, if you simplify that, solve for the displacement S, you're going to get 16.8 centimeters. Thank you very much, and bye-bye.